So in this example, we'll show you how to do structural equation modeling with a latent variable measured by a single indicator. So let's modify the Carmel example. So this is the model we're fitting, and the these are all measured by multiple indicators. But suppose that for job performance, you had only available to you a composite, which would be like a sum or a mean of multiple indicators. This could happen uh, in a variety of situations. One is you obtain secondary data, and all that's available is a composite. So, for example, in the early childhood longitudinal study, they measure externalized problem behaviors and internalized problem behaviors with scales, but unless you have a restricted data access, you only get a composite. So the public data only has the composite to represent each construct. Um, Another situation would be if you were using a covariance matrix from a paper and they only report the covariance for the composite. Um, and another situation would be if you have a very large number of items and you don't have the sample size to do a CFA and get factor scores for that construct or to fit a full SM model with the actual items, then it's not ideal, but you could create a composite and use the composite as a single indicator. Okay, so I'll show you how to do that and how to use the reliability to adjust the error variance of the composite. So here we're creating the composite based on the results here on table 2. Job performance has 4 indicators, so I'll use Mplus to create a sum of those indicators, and then I will I will um, I will do a composite. And then we will use that composite in our structural equation model. So here, what we need from these results, and if we didn't have it here, we would have to calculate, is the reliability. So the composite reliability, which is declared here, started as composite reliability, for job performance is 0.941. Okay, so we need this number. But we also need the variance of the composite, which we can get with any statistical software, but I will show you how to get with Mplus. So the first we need to do is to calculate the composite. So I created an Mplus code. It's very simple. Um, Here at the beginning, I use the define command to create a composite. So performance equals to y1 plus y2 plus y3 plus y4, right? I'm creating the composite here. Um, and I need the variance of this composite. To get the variance, I use analysis type equals basic, which just gives descriptive statistics. So when I run this, and by the way, in the use variables, you have to put the variable you create last, right? So performance goes at the end here of the use variables list. If you put it in another place besides the very end of the list, Mplus will give you an error. So I run these, and this just gives me descriptive statistics. So I have means, covariances, and I want the variance of performance. So this is the covariance matrix. The variance of performance is at the very end. Okay, so the variance of performance is 16.078. Another place to look at it for it is if I scroll down more, I have univariate sample statistics where I have means and variances here. And at the very end here, I have the variance of performance, 16.078. So the two numbers we need is this number, the variance 16.7078, and the reliability, which I know is 0.941 from the paper. Okay, now I will do another code to fit the model. So now here is the SM model. I define the composite here. Obviously, if you are getting the composite from the data, you don't need to define it. It already comes in your data set. And I'm using the composite here. It's at the end of the user variables. I'm going to do mediation, so I'm asking for bootstrap. So the measurement model for the other latent variables that have multiple indicators is here. So notice that it's all variables except the composite. Um, Now, here is the measurement model for the composite. So I call the latent variable job performance and measured by the single indicator, which is the composite perf, right? And the factor loading has to be set to 1. Now, Mplus will do it automatically, but I like to put at 1 to make sure you remember that you did that. Um, these cannot be freely estimated. Um, and then I cannot freely estimate the error variance either. So what I do is I will set the error variance to the observed variance times 1 minus reliability. So I show this calculation here. The, the observed variance is 16.079. I got that from the type equals basic analysis that I just ran. Um, the the reliability is 0.941, which I obtained from the paper. So 16.079 times 1 minus 0.4941 is 0.949. That is the value I should set the error variance to. So here I do that, perf at 0.949. Okay, now the structural model is the same as before, right? Now that the only difference is that job perf is not measured by multiple indicators, it's a latent variable measured by a single indicator. Okay, I will run this. And a couple of comments. Model fit. Model fit will not be the same because in the previous one, I had multiple indicators of performance, which could contribute to misfit. Here, with a single indicator, there cannot be any misfit coming from a single indicator because a model, well, that part with the single indicator is just identified, right? But we can look here and check that there is no exact fit, shown by the significant chi-square, but there is still acceptable close fit, as evidenced by these fit indices. Okay. Now, if you look at the results, this is the measurement model, right? So, um, and here, this is the part where you have the signal indicator. So this doesn't contribute to the fit because it's just one indicator. This part is just identified. Now, and here are the coefficients. So it doesn't affect this, in this case, because the job performance was highly reliable, the reliability was 0.94, you would expect the results to be similar than if you use multiple indicator. And in fact, it's the case here. So let me scroll down to the indirect effect. And here, the total indirect, total direct, the unstandardized is not the same, but the standardized is very similar. So when we use the multiple indicators, the standardized indirect effect was 0.032, now it's 0.33. So it's almost the same. And that's because the job performance was highly reliable, the reliability of those scores was high, right? So you could expect a bigger change if you had low reliability. If the reliability was like 0.6, then the measurement error would be larger. But where the reliability is high, this means that the most of the variance of the indicators is due to the true variable, the latent variable rather than error, right? And that means that even if you use a composite, the results won't change much. Okay, so that's how you do structure equation modeling with a latent variable measured by a single indicator.